In the relentless battle for technological dominance amongst powerful nations, the United States has once again set the pace and surpassed global expectations with the development of an exceptional and extremely lethal weapon that has the world's defense community trembling in trepidation. This recent development has not only confirmed that the U.S. is always at the forefront of technological advancement, but has also raised questions about the insane capability of this weapon. How would this technology impact the global defense community? Does any other innovation come close to this unstoppable missile? Join us as we delve into the capabilities and features of the unstoppable hypersonic missile that the United States just created. Since the 9th century, when China created the very first firearm, the world has witnessed a massive evolution in military technology. Along the line, the United States eventually took the reins in the world of weaponry by creating advanced munitions that the world never even thought was possible. From weapons with limited capabilities to those that a layman cannot even fathom. Thanks to evolution, a new technology with capabilities that has influenced and even changed the dynamics of war has been developed. The creation of hypersonic missiles, a simple yet complex technology, cannot be compared to anything that has ever been seen or used in the world. It is common knowledge that any weapon that has the ability to fly at supersonic speed or that travels at a speed of Mach 5 or faster is considered hypersonic. But when referring to hypersonic missiles, it is not just about the speed. While speed is an important factor in every weapon, hypersonic missiles have more to offer. In a world where weapons are advanced, have almost 100% precision, and can target and shoot down even the fastest weapon, these missiles are designed to move in an unpredictable way to avoid being detected and shot down by air defense systems. Even if they get detected, it would be a challenge to intercept an hypersonic missile. This feature is what makes them really special and well sought after. Interestingly, all the world's intercontinental ballistic missiles also travel at supersonic speeds, some even at an insane speed of Mach 20. However, they cannot be called hypersonic because they follow a predictable path, making it easier to calculate their destinations. This predictability makes them easier to intercept. The difficulty in keeping track of these hypersonic missiles also comes from the type of the weather that they are operating in. They fly higher than slower subsonic missiles, but lower than intercontinental ballistic missiles. To make them even more invisible, these special missiles create plasma clouds around themselves while flying. These clouds absorb radio waves, making it hard for radar to detect them and turning them into stealthy weapons. However, a weapon with this futuristic design is expected to be very expensive. A recent analysis by the U.S. Defense Department showed that developing these weapons could cost as much as $106 million each. Using these missiles a lot would be too expensive for any developing country, especially in intense conflicts. And its cost makes it unattainable for some nations, making it limited to only financially stable nations, but developing nations also need to bolster their defense system as well. Here is one reason why it is expensive to attain. Missiles fly very fast at a speed of over Mach 5 and creates a lot of heat because of air compression. In fact, the heating can make their surface reach thousands of degrees Fahrenheit. To deal with this intense heat, weapon developers make use of advanced and expensive materials. They also make use of special systems that can handle extreme temperatures while keeping the missile's structure intact. Also, because hypersonic weapons move so fast and in complex ways, their body parts endure lots of mechanical stress. This stress is way more than what regular weapons can withstand. To make sure these weapons are strong and reliable, engineers use advanced methods and materials that have exceptional strength to withstand the pressure without causing damage to the missile. The process of testing a hypersonic system is way different from testing other weapons. It involves special facilities like wind tunnels, which are needed to mimic the hypersonic airflow accurately. Also, computer models and simulations are important to understand the complex dynamics, heat, and structural forces that these weapons experience when they are airborne. Precise guidance, control systems, along with strong aerodynamics that enables it to remain accurate and stable when flying at high speeds are very important for these hypersonic missiles. It takes complex algorithms, sensors, and actuators to keep them on track. A solid infrastructure for manufacturing, and also supply chains to develop and smoothly deploy a hypersonic weapon is also important. These complex and efficient weapons have the capacity to disrupt regular defense systems and prevent them from attacking by swiftly striking their targets with precision. Their fast and precise features helps to bolster a nation's military strength and serve as a formidable defense. This weapon can be used to attack and defend. In terms of attack, their mind-blowing capacity, their out-of-this-world speed and agility makes them very difficult to intercept, while their accuracy helps them to attack with perfect precision. Their defensive feature helps to intercept incoming threats with an even greater accuracy over extended ranges to enhance overall security. In light of this, the United States Air Force has unveiled its latest technology, which has made a big impact in the defense world, making experts wonder if anything can stop it. So, let us find out how the United States Air Force made a hypersonic missile so advanced that it can't be intercepted. For almost a decade, the United States and China have been in a stiff competition for supremacy in the development of hypersonic missiles. While China and Russia have earlier made significant progress, the U.S. latest creation capacity and features has shocked them, because not only did it surpass the capability of the already created weapons, it also gave a new definition to what a lethal hypersonic missile should be like. Hypersonic missiles are known to be expensive, but this latest development is expected to save the United States up to $516 million. This alone has set it apart from other hypersonic missiles that have been developed. Like every other hypersonic weapon, it has the ability to fly extremely fast, but is more deadly than any other hypersonic missile that has ever been created. This unstoppable hypersonic missile is known as the Gambit missile. This formidable technology makes use of a powerful engine that can not only fuel massive missiles, but also fighter jets and Navy ships. This engine, which is lighter than the current engines used in jets, provides more power, range, and fuel efficiency. In July 2022, the Defense Advanced Research Projects Agency, or DARPA, unveiled the Gambit missile, which is not like any missile. It is a powerful and destructive hypersonic missile that uses a unique propulsion method called the rotating detonation engine. The rotating detonation engines work by using the power of explosions. The idea of using detonation for power goes back to the 1950s, when Arthur Nichols, an aerospace engineering professor, was among the first engineers to try making a working rotating detonation engine. But the concept of making use of detonation for power was not new, because in some ways, this type of engine is connected to the concept behind Holstead-Nation engines, which are an extension of pulse jet engines. Pulse jet engines work by mixing air and fuel in a combustion chamber, then lighting the mixture to shoot out of a nozzle in quick pulses instead of burning steadily, like in today's jet engines. The mixture burns away slowly with a low energy. A pulse detonation engine is similar to a rotating detonation engine in the sense that both engines make use of explosions instead of a gentle burn. And this is because explosions come with a greater energy and shock waves that is 20,000% faster than a gentle burn. This force results in a thrust from the same amount of fuel and creates a system that can propel a vehicle to speed up to around Mach 5. The United States Gambit missile would definitely be a force to reckon with, especially with the rotating detonation engine that it is expected to improve on. There is the plan to make the engine larger to power the United States fighter jets and the Navy's non-nuclear powered ships, which would give them up to 10% more thrust, a 25% better fuel efficiency, and in turn, save hundreds of millions of dollars. The process of creating this engine for the Gambit program is set to happen in two 18-month phases. The first phase would involve competitors finishing their initial designs with some testing, while the second will finalis designs and end with full-scale flight tests of the rotating detonation engine system. But until the program, along with other American hypersonic programs, gets to their later stages, China will stay ahead in developing hypersonic weapons. Nations worldwide are heavily investing in the research and development of powerful hypersonic weapons, marking a significant change in the modern world of warfare. The United States, in particular, is demonstrating its unwavering commitment to advancing hypersonic technology, and this is evident in the successful test of another hypersonic missile, the AGM-183A Harrow. Interestingly, the United States did not limit itself to the creation of just one lethal hypersonic missile. In fact, it has something mind-blowing up its sleeves. The highly anticipated AGM-183A is an airborne rapid reaction system and advanced hypersonic air-to-ground missile that just completed its first flight test, which took place on December 9th. This test was aimed at evaluating the performance and capability of this new hypersonic missile that the United States has been developing for some time now. For the test, the AGM-183A was selected for an air-launch demonstration to showcase how fast it can adapt and its compatibility with existing aircrafts. It was deployed from the powerful B-52H Stratofortress bomber. Hypersonic weapons like this type can fly at speeds that exceed Mach 5, which is considered 5 times the speed of light. This supersonic speed is one feature that sets them apart from other ballistic missiles because it enables them to evade and fly without getting detected by defense systems. This hypersonic air-to-ground missile was designed to meet the United States military's need to detect and intercept targets swiftly and accurately. This capability would definitely pose a threat to meet the U.S. military needs. The AGM-183A self-destructed after it completed its mission objectives, which is an extremely important aspect of the test for safety and data collection. Now, let's delve deeper into the significance of hypersonic weapons and their global impact. The ability for this hypersonic missile to approach targets stealthily and launch surprise attacks provides a significant tactical advantage. Unlike traditional ballistic missiles with predictable movements, their agility allows them to constantly adjust their flight route and change directions during their mission to make it challenging for conventional defense systems to intercept them. Instead of sending the explosion shockwave out the back of the aircraft for propulsion in rotating detonation engines, the waves move around a circular channel inside the engine, reusing the same thrust repeatedly. Even though some extra fuel is added for this, much less fuel is needed compared to other methods. Also, this engine gives a steady push instead of a pulsing push, like what happens in pulse detonation engines, making it more efficient. Another noteworthy innovation by the United States is the Hypersonic Air-Breathing Weapon Concept project that is being led by the Pentagon's Office of Advanced Research Projects. This project is being developed by Raytheon Technologies, promises to improve and elevate the United States' Air Force hypersonic capabilities to a level where it would remain unrivaled. But while the United States hypersonic missiles are still under the development processes, China's DF-ZF remains the most advanced hypersonic missile in the world. This Chinese hypersonic glide vehicle, which is also referred to as WU-14, by the Pentagon, became officially operational on the 1st of October 2019, China's 70th anniversary. This hypersonic missile is intended to be placed on and deployed from a DF-17, which is a medium-range ballistic missile that is designed to carry hypersonic glide vehicles. The DF-ZF is believed to have the ability to travel at a speed that ranges from Mach 5 to Mach 10 and can deliver nuclear weapons. It can be used for accurate conventional missions, such as an anti-ship ballistic missile. This unrivaled capability allowed this glide vehicle to penetrate the complex air defenses of a United States carrier strike group. This glide vehicle is harder to intercept by using anti-ballistic missile defenses than when compared to regular re-entry vehicles. While the normal re-entry vehicle follows a predictable path through the atmosphere, hypersonic glide vehicles can change course after re-entry and approach the target with a flatter glide, which makes it very hard to detect or even counterattack. While their unpredictability makes them hard to intercept by exo-atmospheric defense vehicles, it also means that they have less speed and altitude near the target, which makes them susceptible to lower-tier defense interceptors, like the Russian Mach 1753 T6 ABM Tree Gazelle. To avoid this, some countermeasures have been put in place, like lasers or railgun technologies being equipped with the missile. But unfortunately, these weapons are not currently available. A vehicle like the DF-ZF can be included in different Chinese missiles, like the DF-21, which has a range of 2,000 to 3,000 kilometers, and the DF-31 intercontinental ballistic missile that possesses a range of 8,000 to 12,000 kilometers. Weapon experts believe that this glider vehicle might initially be used for shorter-range tasks, like targeting ships and other tactics missions. This would offer a temporary solution to the challenge of hitting a moving target with a ballistic missile. In the long run, it would serve as a deterrent against the United States' capabilities, and might even lead to a strategic attack on the United States and other nations. Because regular interceptors always struggle with fast and unpredictable hypersonic missiles, like the DF-ZF that re-enters the atmosphere at a maximum speed of Mach 10 and detection times that are shorter, the United States might focus more on creating weapons that would counter them head-on. However, despite many years of research and development, these weapons are still undergoing several experiments, and it is uncertain when they would become practical or be operational. Glide vehicles present challenges for intercepting them, especially during the misty course phase by defense systems like the SM-3 and GBI. However, these vehicles also have a problem achieving similar success. During the terminal phase, they can only make drastic maneuvers like in the mid-course phase, but not at the terminal phase because of the extreme pressures. Unfortunately, these vehicles cannot intercept maneuvering targets like expensive aircraft carriers, but these are the exact targets that are valuable enough for the glide vehicle to target. These limiting factors have contributed to the reason why the DF-ZF is currently being used as a land attack role only. On the other hand, Russia has also achieved a significant milestone with the Avangard strategic targeting weapon. This weapon possesses the ability to launch hypersonic warheads from intercontinental ballistic missiles, and this poses a serious challenge to existing missile defense systems. The ability to maneuver at lower altitudes makes it different and superior to traditional ballistic missiles. The combination of maneuverability and high speeds poses significant challenges for conventional missile defense. The high speed of the Avangard gives it far better target penetration characteristics than subsonic cruise missiles. Also, Russian Zircon sea-based missile and the air-launched Kinzhal missile also shows the nation's dedication as it forges forward in it being at the forefront of technological advancements. The Zircon 3M22 is a maneuvering anti-ship hypersonic cruise missile that has a range that is estimated at 500 kilometers at a low level and up to 750 kilometers at a semi-ballistic trajectory. It is launched from a ship and can travel at a speed of Mach 9 and is practically unstoppable. The missile was first fired for the very first time in Ukraine. The Kh-47M2, also known as Dagger, is a Russian hypersonic missile that is launched from the air. It is estimated to attain a distance between 460 to 480 kilometers and can travel as fast as Mach 10. This missile has the ability to carry both regular and nuclear warheads. It can be launched by Tu-22M3 bombers, MiG-31K interceptors, and modified Su-34 after the conflict in Ukraine. The missile's design is inspired by the older ground-launched 9K-720 Iskander missile that is adjusted for air launch by modifying its guidance section. The Kinzhal is said to be capable of hitting both stationary and moving targets that includes even aircraft carriers. Its high speed provides better penetration than lighter and slower cruise missiles. While Russian media lays emphasis on the hypersonic feature to create an impression of innovation, the Kinzhal missile is dependent on standard ballistic missile technology at greater speeds. The missile's range is said to be 2,000 kilometers when carried by the MiG-31K and 3,000 kilometers when carried by the Tu-22M3. This includes the aircraft's combat radius added to the missile's range. However, when these missiles are launched from the aircraft, its actual range is estimated to be 460 to 480 kilometers, and this range is similar to the Iskander missile that its design was based on. The K-47 Kinzhal hypersonic missile cost about $10 million. The future of aviation is definitely being reshaped and changed by the development of these advanced weapons, whose speeds, accuracy, range, and survivability are simply out of this world. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.